And it's really, we need to decide, well, how do we decide when something actually is smart for it? Now, I've got a guy coming in at the end of this term who we work with quite a lot. So he runs a company developing smart objects. And he's built his company up from sort of nothing to moving into smart devices around homes and large buildings and the like. And he's got a really sort of good take on this as well. And he'll come in and give lots of good examples to it. And he also takes on, he likes to take on 2 or 3 of our students every year to sort of go and work with him. So he's a nice guy to get to know, a chap called Jet Tool from Tool Systems. But we need to decide, well, what makes something smart? What differentiates, say, this table here from a smart table? When could I call this table smart? Or when could I call this, one of the desks in front of you smart? Or something, Is there such a thing as a smart table? Does it? Yeah, go on, sorry.
Does it, like, if it has sensors?
If it has, yeah, I mean, the response there, if it has sensors in, does that make it smart? It's on the way. It's on the way. What might be useful is like, I've just sort of, I'm sick of carrying those keys, but I walk out of here and I can't remember where I left my keys to it. Now a smart table could know what's on top of it. So a smart table would know where it is. It's in LT3 of Jeffrey Manton building. Currently it's got on top of it some sort of pamphlets, some keys, camera, power supply and things like that. So what a smart object does, it does everything that it's supposed to do. It supports the table, supports things, you can put stuff on top of it basically, but it can do things a bit better and communicate things about its environment. It's context aware and tell that back. So the table could sort of recognise that I've gone out of the room and say, you've left something there for it. It might be that the keys themselves are smart. The keys might know where they are. Yes, I'm trying to turn this on. Do the keys know where they are? Oh, they're my wife's car keys. Turn over to mine. My keys seem to think. So that's where they are. They were last seen at 11 o'clock for it. I've just told it to look for them, and hopefully it's going to sort of change its map position to come up with sort of where it is. Yeah, a lot of people are applying to join the Facebook group. There. One of the things about this this particular tracker application, it works not just for your keys, but it'll also detect everybody else's keys. And it works in a sort of social way. If I say I've lost my keys, this works through a hub. That's like the sensor for it. That's the hub. So it comes from that light bulb and that white hub to find it. This is the thing that communicates with the outside world, and the sensor can talk to a phone up to within whatever low power Bluetooth range is, about 20 meters or so. But it could receive a signal from the tracker home site and say, can you just look for any other keys in the area? And if I lose my keys, my phone might not be in the area, but if somebody else is running that software, they could detect my keys and in the background pass a message on to me saying your keys are still in LT03 or whatever sort of room you left them in the first place. That's a company called Tracker, T-R-A-K-R. They're quite a common thing to sort of have. But what makes it smart is that bit to be able to interact with its surroundings, to be context aware, and to do something about it, to make that keyring a bit better than a normal, just straightforward, little picture of somebody like that within it. So we're moving on from these things like phones and computers, devices that have perhaps already got communication built within them. We've got other objects, home appliances, vacuum cleaners, cars, powered objects, but don't normally have communication to it. You've got objects that don't have any communication or any power supply. Straightforward furniture, clothing, stationery. The things where we get everything connected is where we give all of these the ability to communicate and the ability to know something about their surroundings. Now, it doesn't mean that you're making that set of keys, that key ring, into something that can do calculus or something like that, or knows the presidents of the United States, all that sort of thing. It's just smart in that it can do its own task a bit better, to know something about its environment, to be able to interact with it, and then communicate that outside. And that's what we'll be looking at when we do our nodes. A smart device is just a thing, but it's also got some sort of ability to detect something in its environment. Whatever that sensor is depends on, well, what type of thing you're dealing with. Those fidgets, for example, we've got something like 6 or 7 sensors in there, but they've got hundreds of sensors on their home sort of site. And you can get sensors to detect just about everything, and actuators or actual sort of type. The thing itself will typically have some sort of processing power, and we'll explore these next week for it. But also the key to it is this ability to communicate, to be able to send some information out about its surroundings to the outside world. Now that's going to be sort of quite tricky, because certainly this little key fob doesn't have enough power to be able to sort of connect to Wi-Fi, for example. You know how long Wi-Fi lasts on your phone if you leave it on all day? It lasts about a day, something like that, before it sort of gives up if you're doing a bit of heavy sort of stuff on that. Wi-Fi is typically very sort of costly in terms of power usage. So there's other communication ones that we can use, Zigbee and low power Bluetooth are some of them, and other ways in which we can get this thing to be able to communicate with somebody over in India or Australia or something like that. Typically working through a sort of communication node, and you get it communicating from one to another. This can then pass on the message. And that's some of the ideas that we'll be looking at. A thing becomes a bit smart if it can detect something about its environment or affect its environment in some way with an actuator. It can do some relative amount of processing and can communicate. And they've got this idea as well. They should be mobile in general for it. They should always be on for it, detecting things about the environment. And these pose their own problems to it. They may well have multiple sensors built in. Some sort of improved human-computer interaction. Doesn't necessarily have to be a screen. It may just be a flashing light on it. It may be something that vibrates. But just some way of interacting with a human being that allows them to understand what's sort of happening to it. And you can make them better with sort of increasing their storage and their sort of processing power and the like for it. So in terms of building our smart devices, and as I say, this is what we're going to be doing in the labs, building it up bit by bit. We've got a tiny one at the first week. We're looking at collecting that data in some way, interacting with the human beings, processing, storing the data. These different sort of roles. Smart devices acting as a sensor in some way, collecting that sort of data from around it, acting as a user interface. So some nice way of providing messages to your user, maybe just to confirm what they've done. I mean, how many people, they've done a lot of these sorts of things on phones. You have a lot of feedback to the user as you're actually, for example, tapping buttons. You can get it bleeping, as you go bleep, 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 as you're doing the phone number for somebody. That gets really annoying to other people around it. Or even just a little click. It might vibrate your phone as you're doing it. So as you touch something, it gives a little vibrate so you know you've done it. The whole thing falls into the human-computer interaction of providing some sort of feedback to the user to control their environment for it. And when we're getting these smaller and smaller things, how that feedback's given can be very sort of different to it. Smart devices may be equipped, so it doesn't necessarily have to be equipped, but they may be equipped with relatively powerful processors. Again, I'm just sort of looking this one out for this week. This little key tag, that's got a processor in it. Now certainly it's not a processor that's big enough to power your laptop, not big enough to power your phone, but it's big enough to be able to control, say, a little Bluetooth transmitter for it, and receive information. And that's really all it's wanting to do, is to receive messages and send messages out to where it is. It may even have a location sort of chip built into it. But because it doesn't need to do too much, it doesn't need to transmit so far, the processor might be sort of very little, and so you're back into using some of these really old processors that don't need to do much. Not every processor needs to be ultra fast, loads of memory, working at sort of really high speed. It means that these things can then be really cheap, is the bottom line to it. When you're buying processors for things like that, they have to cost less than pennies even. You can't have something that you want to sell for £10 with a processor that costs 50 inside it. You've got to have the electronics inside it has got to be sort of cheap enough for it. But they've got to be useful enough to be able to perform whatever tasks they've got. So one of the sessions we'll be having a look at is what sort of operating systems these processors run. That little key tag doesn't run Windows 10. It doesn't run Linux, it doesn't run Mac OS.